Okay, so here's a solution for test 3. So problem number 1 was a law of sines problem. It was angle, side, angle. So the first thing we do is we can find the third angle. So that would be 180 minus 63 minus 39. And that comes out to 78 degrees. Most people got that correct. Let's label them now. We'll call this angle A. Call this side A. Call this angle B. This angle C. So this is going to be side B and this is going to be side C. It's opposite. So then we just have to use the law of sines twice. So we do know the sine of angle. We know angle A and we know the sine of angle A. And we know angle B, so we could find the sine of angle B. So the only unknown that we have for these two ratios is the side B. So if we solve for B, this goes up there. The sine of B stays over here. This one comes down. And then this one goes up. So that's solving for B. So we get the sine of angle B, which is 39 degrees, divided by the sine of angle A, which is 78 degrees, as we just figured out, times 9. And if you do that, you get 5.79. And you could do the same thing for C. So we can do is replace B with C. So it's C equals the sine of C over the sine of A times A. So then you'd have the sine of angle C, which is 63 degrees, divided by the sine of angle A, which is 78 degrees, times 9. So that gives us C is equal to 8.20. So we can put those on our graph, or our picture. And we get that. And again, we can kind of look for order of ranking. Smallest angle, shortest side. Next smaller angle, next shortest side. Largest angle, largest side. So those all agree. Now the second problem is the law of cosines problem, because I have a side, an angle, a side. So I'm going to call this side angle A. We'll call this side B. We'll call this side C. And so the first thing we can do is we can find side A. So this is side A right here. This would be, here's angle A. This is side C, so this is angle C, and this is side B, so this is angle B. So the form that we use is A squared. The length of the opposite side is B squared plus C squared minus 2BC times the cosine of the angle A. So if you plug in what you have, 60 squared plus 55 squared minus 2 times 60 times 55 times the cosine of 132 degrees, we get A squared is equal to 11,041, and if you take the square root you get 105. So now we have all three side lengths. So now we just have to use the law of sines to find one of the other two angles. So let's solve for the, so what we'd have is the sine of A over the length of side A is equal to the sine of angle B over the length of side B. And what we're trying to find is angle B, so we'd solve for the sine of angle B, and that would be, bring that up there, so you'd have B over A times the sine of A. So B was 60, side B is 60, side A is 105 times the sine of 135 degrees. And so this gives you the sine of A, the sine of B. So to get B, we just take the inverse sine of 0.425, and that comes out to be 25.1 degrees. And then you can find C. Angle C is just going to be 180 minus A minus B. So you have 180 minus A, which is 132, minus B, which is 25.1, and you get 22.9 degrees. So this angle B is 25.1, and this angle C is 22.9. Okay, the next problem. So we have the angle between the horizontal and the position of the factory is 8 degrees. The angle between the horizontal and the position of the river is 12 degrees. So you'd have like some kind of sighting thing in your airplane to get those angles. And from the map, you'd know that this distance is 5 miles. Okay. So what we're going to end up with is a triangle. And the triangle of interest to solve the first part is this one. Not a right triangle, but a non-right triangle. So let's go ahead and bring that over here so we could look at it without all this extra stuff. And let's see if we can put some numbers to the different sides. So this is 5 from the factory to the river. If we call this side A, this would be angle A. Now, looking up here, you can see it's 8 degrees to here and 12 degrees to there, so the angle between these two is 4 degrees. And notice this is transversal, 2 parallel lines, the ground and the flight. So this angle B is 8 degrees. So we'll call B here, call this side B. So this is 8 degrees. So now we've got 2 angles. So angle A is 180 minus 8 minus 4, which is 168 degrees. So that's 168. And so this is just like the first problem. Now we have all 3 angles. And so what we can do is, if this was B and this must be C, so this is side C. So what we can say is that the sine of C over length C, and we want to find length A, that's the straight line distance. So you have the sine of angle A over A. So if we solve for A, bring that to the numerator, keep this over here, bring that down, and then we multiply by C. So we know everything. Sine of A is 168, or 68 degrees. Sine angle C is 4, sine of 4 degrees times 5. And if you plug that in, you get 14.9. So it's 14.9 miles. This distance right here, 14.9. Now the second triangle is a right triangle, and I mentioned that in the problem. So let's draw a line here. So here's this side, which we know now. We have the height, which is what we're trying to calculate, and we have this distance, which we can calculate, but it didn't ask you to calculate. So now we can move those over to another page and reconstruct our triangle and put some numbers on it. But because it's a right triangle, it's just right triangle geometry. So let's see what we can say. Well, what do we know here? Well, we know this side is 14.9. We know this angle is 8 degrees because you've got this 8 degrees. It's a common angle between the two. And this is a right angle. So what we're trying to do is figure out this distance. So if we got an angle length, the opposite side, length of the hypotenuse. So we know that the sine of 8 degrees is equal to x over 14.9. So if you solve for x, it's going to be 14.9 times the sine of 8 degrees, which is 2.1 miles. So that's 2.1 miles, which is about 10,500 feet, which is not unreasonable for a propeller aircraft. Okay, so those are the first three. The next one is just some vector addition. We had vector u is 3, 4, and vector v is 7, -2. So you can kind of just sketch those. 3, 4 would be something like here, and 7, -2 would be probably about maybe there. Okay. So if we do u plus v, we just add the components together. 3 plus 7 is 10. 4 plus -2 is +2. So that's the answer for the first part. Now the second part, it's u minus 4v. So the first thing we need is, what is 4 times v? Well, you just take v and multiply each component by 4. So you get 28 and -8. So 7 times 4 is 20. -2 times 4 is -8. So what we're going to have is u, 3, 4, minus 28, -8. And so 3 minus 28 is -25, and 4 minus a -8, so it's 4 plus 8 is 12. So that was the second part. Number 5, that was pretty easy. So, the x component, which I'll use u sub x, was 3, and the y component, u sub y, is equal to 2. You could also write unit in unit vector notation. Use 3i plus 2j. Either one of those is okay. That's 5. 6. So what you were given was a point. Well, you're given the vector, but the coordinates of the vector represent a point in space. So you go -2 and 4. So you here, and the vector is a line from the origin to that point with the arrow pointing in that direction. So you've got a direction theta, and you got some length r. So the magnitude of the vector v is just equal to the square root of the components, -2 squared and 4 squared. Now, a lot of people made this mistake in that they squared 2 and then made it negative, but these terms are always positive, so you never should have a negative. Because you can think if this were -4 and this were 2, you'd end up with a negative square root, which makes absolutely no sense. So you end up here with -2 squared, which is 4, and 4 squared, which is 16. And so the magnitude was the square root of 20. Now to find the angle, you can use stuff you learned in chapter 4. So one way would be to think about, the cosine of theta is going to be it's x over r. If you take these coordinates, and r is the square root, well, r is equal to the length, which is the square root of 20, and x is -2, so you get -2 divided by the square root of 20, or theta is the inverse cosine of -2 over the square root of 20. And you'd end up with 117 degrees. Now, that works with the cosine in the first and second quadrants, but so that's not really completely generalizable. That's a word. Probably the more general way of doing this would be to find this reference angle, and I could use the inverse tangent. I could say that theta, the reference angle, is the inverse tangent of the y change. This is the absolute value, 4 over -2. And if I do that, I'll get 63 degrees. And then the second quadrant solution, this is in the second quadrant, is 180 minus the reference angle. Or I should have done this in radians because I did ask you guys to do it in radians. So you just have to, so let me do it in radians as well. So if we do the inverse cosine of -2 divided by the square root of 20, we get, so in radians it's 2.03, and if you divide by pi, you get 0.648 pi radians. And if you take 2.03 times 180 divided by pi, you'll get 116 degrees. You get the same answer. So down here, if you did it in radians, you take the inverse tangent of 4 divided by 2, which is 2, which is 1.107 radians. And if you divide by pi, you get 0.352 pi radians. So if you take 1.107 times 180 divided by pi, you get 63 degrees. So, now to get the angle here, you take 180 minus 63 degrees, or pi minus 0.352 pi. So this is 117, or whatever 1 minus 0.352 is, 0.648 pi. So both of these are in the second quadrant. So if you did 63 degrees or whatever, you got points taken off. Okay, next one, you're given some vector W, which is in the first quadrant, and I asked you to find the unit vector. So I'm going to call U the unit vector, and that's equal to the original vector divided by the magnitude of the vector. So all we have to do is find the magnitude of the vector, which is the square root of 5 squared plus 7 squared. Now, because neither one are negative, we don't have to worry so much about it. But if you do that, you'll get 74, 49 plus 25. So that's the magnitude. So the unit vector is going to be 1 over the square root of 74 times the W vector, which is 5, 7. And you can take that inside, the scalar inside, because what this is I guess it is a unit vector in some ways, but it's better to bring this magnitude inside. And then finally, you would want to rationalize it by multiplying by the square root of 74 and divided by the square root of 74, so that you get rid of that square root in the denominator. So that's the answer. So unit vectors, all you have to do is take the magnitude using the Pythagorean theorem. Make sure if there's any negatives, that you square the negatives, not negative of the square. Okay. The next one, number 8, I asked you to find the angle. So the equation says the cosine of the angle between two vectors is the dot product of the two vectors divided by the magnitude of the two vectors multiplied together. So we just have to do the dot product, get the magnitude, stick it in there. It'll give us the cosine, then we take the inverse cosine. So let's do u dot v. So u is 3 comma 5. V is negative 2 comma 4. So you multiply the components together. So you get negative 6 plus 20, which is 14. So that's u dot v. The magnitude of u is the square root of 3 squared plus 5 squared, which is the square root of 34. The magnitude of vector v is the square root of negative 2 quantity squared. So you get 4 plus 16, which is 20. So that's the magnitude of v. So now we can plug it in. So the cosine of theta is 14 divided by the square root of 34 divided by the square root of 20. If you plug that into your calculator, you get 0.5369. And if you want to find the actual angle, you take the inverse cosine of 0.5369, which is 57.5 degrees. So that's the angle between those two. And if you plotted this, if you plotted these two vectors, this is 3, 5. So 1, 2, 3, 5. That's probably about up here somewhere. And then negative 2, 4. So you got negative 2, 4. So that's about here. And the angle, this is theta. And so that 57 looks pretty reasonable. Okay, next one is this projection. So the formula was the projection of vector u in the direction of vector v is, again, u dot v, just like the previous one, but you divide by the magnitude of v squared. So this is a scalar, and these are scalars. So you take the scalar and then multiply by v, the vector v. And what that does is it basically scales the vector v to either make it longer or shorter. So again, let's put what is u. U is 2 comma 6, v is 3 comma 5. So u dot v is going to be 2 times 3, which is 6, 6 times 5, which is 30. So u dot v is 36. And the magnitude of v squared is just, you do v, not u, so it's just 3 squared plus 5 squared. Because v, the magnitude of v is equal to the square root of this, so if you square it, you get rid of the square root sign. So that's 25 plus 9, which is 34. So this projection is just 36 divided by 34 times vector v, which is 3 comma 5. And if you multiply that out and simplify it, it becomes 54/17 and 90/17. And that's because you can see this could reduce down to 18 over 17. So 18 times 3 is 54, and 18 times 5 is 90. So that is the projection of vector u in the direction of vector v. Okay, the next one is just completing the square. It's kind of funny because a lot of people made mistakes on 10, but then did 11 correct. Okay, so what we're trying to do is take these two terms that involve x and make it into a complete square. So first thing, you have to factor out whatever the coefficient is in front of x squared, which in this case is 4. And you factor it out of both terms. I'm going to go ahead and move the 23 to the other side, so it becomes negative 23. Now we take the coefficient here, negative 4. A lot of you people are thinking positive 4. You got to really pay attention to the sign there. So it's negative 4 divided by 2 squared, which when simplified is negative 2 squared, which is 4. And so you guys are like, oh yeah, I get the same answer. I don't need to worry about the sign. The problem is when you complete the square here, you got used the wrong number. It's always this number. I told you guys a million times. So you get 4 times x minus 2, this number, x minus 2 squared. Oh, I forgot something, didn't I? So I added 4 inside the parentheses, so I'm adding 16, so I have to add 16. So 23, negative 23 plus 16 is negative 7. And that's the answer I was looking for. Now, number 11. So this is the kind of one that you might expect for hyperbolas and parabolas. I mean, if you know how to do this, you also know how to do it if it's given to you in standard form. So, okay. So, group the x terms together. Group the y terms together. Move the constant to the other side and change the sign. Okay, now for the x terms, we have a coefficient of 16 in front of x. So we have 16 times x squared. 96 divided by 16 is 6. Leave some space. Then we have the y. There's a 9 in front of y squared, so we have 9 quantity y squared. 36 divided by 9 is 4, so it's negative 4y. Leave some space. Right hand side. Again, take negative 6 divided by 2. Square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Add 9. But I'm actually adding 9 times 16, which is 144. So I'm going to add 144 over here to balance that out. Now here I take negative 4 square divided by 2, square that. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I add 4. You know, you always add a number here because you're always squaring it. But when, okay, I'll get sidetracked here. So we're adding 9 times 4, which is 36. So I'm going to add 36 over here. So we can take the first term and make that into a complete square using negative 3. In the second one, we can make that into a complete square using negative 2. And on the right hand side, these cancel out and you get 144. Okay, so let's divide both sides by 144 because the standard form for an ellipse is equal to 1. But we want to have all these constants in the denominator. So this 16 goes all the way down into the denominator of the denominator. Likewise here, the 9 becomes the denominator of the denominator instead of the numerator. And these, luckily for you, are nice numbers. 144 divided by 16 is 9. 144 divided by 9 is 16. So there's your equation in standard form. So what do we know? We know A is 4 because A goes with this thing. So this is where a lot of people made the mistake. A always goes with the larger of the two. B goes to the other side. So this is b squared, this is a squared. Now, for an ellipse, c squared is a squared minus b squared. So a squared is 16, b squared is 9. You get 7. So c equals the square root of 7. Now we don't need this to plot it, but we will plot it. We also know the center. So we look where x is, because usually we have x first when it comes to ellipses and y second. But so we got x equals 3 and y equals 2. So that's the center. So we're going to plot the ellipse, and then we'll come back and get the coordinates. So first thing you do is plot the center. 1, 2, 3, 2. So there's the center. The A goes with the y direction. So we go 1, 2, 3, 4 up here. 1, 2, 3, 4 down. So the major axis is in the y direction. That's because the biggest denominator is underneath the y. Then you go 3 units the other direction. 1, 2, 3 here, 1, 2, 3 there. And then finally, the focal points are always along the major axis, which is this way. So this is major, this is minor. So we go square root of 7 is 2.65. So we go 1, 2, 2.65, down 1, 2, 2.65. Now again, we don't need those to do this ellipse. So we do a horizontal line here, horizontal line there. We're trying to make a rectangle. And then we start here and then kind of loop around, go through that point, go down there, come around like that. Okay. Sometimes people draw these a little too sharp. And the focal points, of course, remember, are the distance from here to a point on the ellipse plus the distance from there to the other focal point remains constant for any point on the ellipse. That's the whole idea. Okay, so now the coordinates. Well, we have the center. The vertices are along the major axis. So you can see everything here, all of the points for the ellipse that we want the coordinates for are at x equals 3. So it's going to be 3 comma something, 3 comma something. Same thing for the foci. It's going to be 3 comma something and 3 comma something. Okay, what is that something? Well, we started here at y equals 2, the center, and we went up 4, 2, 3, 4, 5, 6. Started here at 2 and went down 4, 2, 1, 0, -1, -2. Now for the foci, we only go 2.65. So you start at 2, 3, 4, 4.65. And now going the other way, 2, start at 2, go to 1, 0, and then another 0.65, so it's negative 0.65. So that's the problem. A lot of people got these oriented in the wrong direction. They had a horizontal major axis, but the major axis always goes with the larger denominator. It's that simple. Okay, so that's the test.